We now discuss the solution of a problem from the section Sequences and Series. The question is related to the concepts of arithmetic progression. This question has appeared in the joint entrance examination main held on 6th April 2023 in the first shift. The given question is, let A1, A2, A3, etc. An be n positive consecutive terms of an arithmetic progression. If D is positive, if D greater than 0 is its common difference, then limit n tends to infinity of under the square root of d by n into 1 by root a1 plus root a2 plus 1 by root of a2 plus root of a3 plus etc. plus 1 by root of an minus 1 plus root of an is, we are given four options. Option 1, 1 by root d. Option 2, 1. Option 3, root of d. Option 4, 0. We are given a1, a2, a3, an as the n positive consecutive terms of an arithmetic progression, and we are also given the common difference d greater than 0. Then required to find the value of limit n tends to infinity of this expression. We now discuss the solution of the problem in detail. We have a1, a2, a3, etc. an are consecutive terms of an arithmetic progression with common difference d. It is given each of the terms a1, a2, an is positive. So, given ak greater than 0 for all k is equal to 1 to n. Further given d is positive. Agreed. So first we take the expression that is given in the bracket, then afterwards we will consider the limit. Right. So now 1 by root of a1 plus root of a2 plus 1 by root of a2 plus root of a3 plus etc. plus 1 by root of an minus 1 plus root of an. Now rationalizing the denominator in each of the terms, then we get the rationalizing factor for the first one is root a1 minus root a2. When you multiply both numerator and denominator by the rationalizing factor, then in the denominator you will get a1 minus a2. Likewise, we do in the other terms also. This is equal to root of a1 minus root of a2 by a1 minus a2 plus in the second case root of a2 minus root of a3 by a2 minus a3 plus etc. root of an minus 1 minus root of an by an minus 1 minus an. Now a1, a2, a3, an are in arithmetic progression. Therefore, a2 minus a1 is a common difference d, a3 minus a2 d, etc. an minus 1 is also d. So each one sitting in the denominator is minus d because it is a1 minus a2 is here, therefore it's minus d. So we have written minus d in the denominator. Now we take out minus d, 1 by minus d as common. So that will be minus 1 by d into this one, root of a1 minus root of a2 plus root of a2 plus minus root of a3 plus etc. plus root of an minus 1 root of an. So what we see is root of a2 cancels, root of a3 cancels with root of a3, root of an minus 1 cancels with root of an minus 1, ultimately left with root of a1 minus root of an. Agreed. And we have taken this minus inside, so we have written it as 1 by d into under the square root of an minus square root of a1. Now let's get into the limit. Therefore, limit n tends to infinity square root of d by n into the whole expression 1 by root of a1 plus root of a2 plus etc. plus 1 by root of an minus 1 plus root of an is equal to limit n tends to infinity limit n tends to infinity of under the square root of d by n into the above 1 by d into square root of an minus square root of a1. We continue in the next slide. Right. So that's what we have. So that limit is equal to limit n tends to infinity root of d by n into 1 by d into square root of an minus square root of a1. So this root d into 1 by d will be 1 by root d, and we are left with 1 by root n. Push it inside the bracket. So that will be equal to limit n tends to infinity 1 by root d into, and this root n when pushed inside the bracket, it will be under the square root of an by n minus under the square root of a1 by n. And limit of the difference is equal to difference of their limits. We write 1 by root d into limit of the first minus limit of the second. Now see, the limit of the second, limit n tends to infinity, root of a1 is constant, 1 by root n will be 0. This will be 0. This will be 0. So we are left with this one. For an, what is an? The nth term of the given arithmetic progression. So what is the nth term? a1 plus n minus 1 into d, because a1 is the first term. So this will be 1 by root d into limit n tends to infinity under the square root of an is a1 plus n minus 1 into d by n. So that will be equal to 1 by root d limit n tends to infinity of under the square root of a1 minus d by n plus nd by n. So n cancels, d you are left with d. So as limit n tends to infinity, a1 minus d by n will be 0, and you are left with under the square root of d. So will be 1 by root d into root d after taking the limit, and root d cancels, and that will be 1. So the answer to this question is 1, which is appearing at the option 2. So the answer to this question is option 2, that namely 1 is the answer. So that is the detailed discussion of the solution of the problem from the subsection arithmetic progressions. It is definitely a good question, and in one way it is an easy question also. I am sure that every student might have done this question in the examination. Right. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.